Hello everyone, welcome to Predictive Logistic Regression Analysis with RapidMiner. This is Reza Wazi and this tutorial is loosely based on Dr. Matthew Nurse's Data Mining for Masses book. Similar to other predictive analysis, we are going to have two datasets here. One is the training dataset and the other one is the scoring dataset. We will use the training dataset to train the computer and build the model, and we'll apply that model on our scoring dataset in order to predict our variable of interest. Now, let's get to know the dataset that we are going to use for this specific task for the logistic regression. I have already imported the dataset that we require for this task, and those are heart attack training and heart attack scoring. Let's go ahead and take a look at the heart attack training. Yeah, I dragged and dropped it in the process window, and now I'm going to run this very basic model to get a better understanding of my training dataset. You can see that I have already flagged second heart attack as my label variable, or my target variable is my variable of interest. Now let's get to know the dataset a little bit better. Age refers to the age of the person in years. Marital status is a categorical variable that can take 0, 1, 2, and 3. 0 for single, 1 for married, 2 for divorced, and 3 for widowed. Then we have gender, which can take 0 or 1, 0 for females, and 1 for males. And then we have weight category, which is 0 for normal weight range, 1 for overweight, and 2 for obese. Then we have cholesterol. This is the person's cholesterol level as recorded at the time of their treatment for their most recent heart attack. And then we have stress management, which refers to whether or not the person has previously attended a stress management course or not. 0 for no, 1 for yes. And then we have trait anxiety, which is a score on a scale of 0 to 100, from no anxiety to almost always stressed. So this dataset, the training dataset, is coming from a sample of patients who either had their second heart attack or not, but they all had their first heart attack. So they came into our clinic and their demographics was recorded, plus few other information. We want to use this past data of people who contracted their first heart attack and some of those who contracted their second heart attack in order to predict people who are in danger of contracting a second heart attack. Those people who already contracted their first heart attack, they came to our clinic, and now we want to use this past data, this old data, in order to predict the risk of contracting a second heart attack. And that's what our scoring dataset is. Let's go ahead and take a look at our scoring dataset, heart attack scoring. Once you run it, you can see that it contains all those variables except the second heart attack. So this dataset, the scoring set dataset, is of people who already had their first heart attack, and we want to see if they are going to contract a second heart attack, or they're in risk of contracting a second heart attack or not. So as you can see here, our label variable, or the variable of interest, is a binary variable. It can only take yes or no. But here at the time of importing, RapidMiner recognizes it as polynomial instead of a binomial or binary variable. What we are going to do, we are going to use logistic regression to model this, to figure out how these different variables are affecting the chance for the patient chance for the second heart attack, and then apply that model to our scoring dataset. One thing that is important in almost all of predictive analysis tasks is that to make sure that that your training dataset is representative and balanced. What it means that your training dataset, the label variable in your training dataset, should have equal numbers or very similar numbers of each cases. Here, if you look at the second heart attack in our training data set, you can see that we have 70 cases of people who did not contract the second heart attack and 68 cases of people who did. So we have similar numbers. If you are doing a multinomial logit regression, then you probably have more than 2 categories. You have to make sure that there are similar numbers of cases within each category. Another thing that you have to make sure is that to make sure your scoring data set is within the ranges of your training data set. What it means is that you have to check and make sure that the values of your scoring data set fall within the lower and upper bounds of the corresponding attribute values in your training data set. Here, if you check the lower and upper bounds, and go back to the scoring dataset, you can see that the scoring dataset, they all fall within the lower and upper bounds of the training dataset values. Look at the cholesterol is 122 minimum, maximum 239, 122 to 139. So it's within range. And look at trade anxiety, within the scoring is 35 to 80. If you go to training, it's 35 to 80. So what it matters is that the training data set should include all ranges that already is within the scoring data set. So the values of the training data set should include all the values that exist in the scoring data set. And this is important because the training provides an example for the computer to learn. So if in your scoring data set you have values that they're out of the training range, you have attributes with values that are out of the range that the training dataset covers, it means that the computer does not have an example for those ranges to learn and to accurately predict what will happen. So this is an important issue, but for some algorithms, some methodologies, it is more pronounced than others. Logistic regression is one of those that is more sensitive to these matching ranges issue. Okay, now let's close these two and go back to the design. We want to build a logistic regression model using our training and then apply that model into our scoring data. Let's go ahead and do that. Here's the logistic regression. And the logistic regression operator in RapidMiner accepts both nominal and polynomial labels as input. So we are not going to have a problem here. And next step is to apply this model, the logistic regression model, the created model, into our scoring dataset. Let me again change the names of these operators for you. Training and scoring. Let's go ahead and use the apply model. Take the output model port from the logistic regression to the input model port of the apply model and unlabeled data. Now what this operator will do will go ahead and apply this logistic regression model that is built off of our training onto our scoring data. And you can get both lab, which is basically the results of the prediction, and you can get the model, which is the model that is created in this step. Let's go ahead and run this RapidMiner model. So I'll give you some model description. Since logistic regression use a logarithmic function, interpreting the results is not as easy and straightforward as the results of a linear regression. Now let's go ahead and take a look at the results. You can sort your results based on the confidence for yes. So those patients that we are more confident, or this algorithm is more confident that they are going to contract a second heart attack, they are placed on top. Now let's take a look at the list of patients. As we scroll down, the probability for confidence yes will decreases, and the probability for confidence no will increases. And on this case, you can see that because we have more odds for this person not to contract a second heart attack, the computer or the algorithm is categorized it as no. But let's take a moment and think about implementation. So what does this mean? Can you just go ahead and call these patients up and tell them, hey, the computer program told us that you are in the danger or you're in the risk of contracting a second heart attack, especially in cases like this. There is just slightly more chance for this person to contract a heart attack than not to. So what are we going to do with these results? Remember, in all predictive analytics, you always have to rely on your domain knowledge more than the output of the modeling. As you will learn in the cross-validation, you will see that many of these models are not really accurate. So they only can give you 60 to 70% accuracy. It means that in general, they are wrong in 30 to 40% of the times. So if you only rely on the results of these modeling, on the results of predictive modeling using data mining methodologies, any data mining methodologies, let's say it's regression, it's logistic regression, neural nets, decision tree, if you only rely on the results of these predictive modeling, I guarantee you that some point in the future you are going to lose your job because these are not accurate. You can only use these predictions as an extra piece of information, to make a more informed decision. You should never completely rely on the computer output or on a predictive analysis algorithm output. Okay, that was it. That was the whole process of predictive analysis using logistic regression on RapidMiner. Again, you will apply your logistic regression model on your training dataset, and then you will apply the created model, the logistic regression that is created off of your training model onto your scoring model. And then you will get both model and the predictions for your model for your effort.